Good morning. Good morning, everybody. Namaskar. This is Suraj Singh speaking from Bharat, India on this day, February 21, 2022, Sunday, 3:50 a.m. नमस्कार, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक फरवरी 21, 2022, सोमवार सुबह के 3:50 I'm just again back to you about talk, continuation of video series. You can call it series now because there have been so many videos in this talk that is pertinent to quality, project works, quality projects works, coordination world. These are two dominating titles. You can say quality on projects and also quality in general, as well as coordination world, which is very important. Coordination engineering, you can call it, communication network, which is foundation of coordination engineering, and of course concrete significant material. And then civil field engineering, you can say civil field engineering, reliable engineers and contracts, safety designs, construction methods, which are all related to engineering, and you can say quantum as well as quantity and quality, and claims, you can say claims are related indirectly and directly to something like that. And you can say this my email ID suraj_suraj_engineer, engineer spelling as usually NGINNER at yahoo.co.uk. This is important for you, suraj_engineer at yahoo.co.uk. And my title is Chartered Engineer India, formal title in India at national level as well as worldwide. You can say also International Professional Engineer India, which is under provision of IPEA, International Professional Engineers Agreement at world level. India has representation through Institution of Engineers India, and that is this one. And next one is 2025 September 30 and renewal for another 5 years. And then this is Chartered Engineer India certification, which is related to corporate membership of Institution of Engineers India, and this is corporate membership fellow as well as. You can say I close these files now for purpose of clarity so that I can continue my talk on quality as well as coordination engineering, which is very important issue nowadays. I am inclined to concentrate on coordination engineering, projects and public and engineers, and quality and coordination is the combined title that I speak about. Quality is one part, coordination is another part, because both are related. If we miss something in coordination, we miss something in quality as well. Bharat India speaks about, I say particularly for my nation, Bharat India, my land, my state, in which I was born. I am a part of that, original part of that. But of course, Bharat is my country, but you can say first country is world, planet is world, so we cannot deny this fact. Permanent home is world and sub home is Bharat India. So I am concerned with both, but I am very concerned due to deteriorating situation of quality, state of quality, and absence of coordination in our country. And I think its same situation applies to all other countries as well in this digital, so-called digital world. Because digitized it has been, but coordination has gone somewhere, I don't know where. Same way, quality is not fixed anywhere. Quality is not fixed anywhere in any part of world, and particularly in our country. And if you see quality of other countries, you shall find fluctuations everywhere. Nowhere you can say it is guaranteed quality or good. Coordination is absent, you can say. If you see now in this computer world, digital world, network world, coordination values negative, zero, or you can say it got no value. It used to be something in past when world was not digitalized, but now coordination has gone also to unknown state, unknown place. And that's my concern here. To be very frank, I say quality and quality. If we keep hidden, Bharat India speaks now. I say time speaks now. Let us say time speaks. Quality and coordination are very important. And even I say coordination, I forget for time being. What about quality? Is it only word? Is it only term? It's only title? Is it a subject? Why is that? Why are we not serious about quality? If we are not serious about quality, then how can we sell our products? How can you sell our services? You think your car is air conditioned, it's beautiful. Can you sell your services through car? You cannot. Can you sell services through a beautiful house? You cannot. Can you sell services through your beautiful showroom? You cannot. Then how can you sell your services? Yes, maybe first time customer gets you a chance to avail your service, but maybe first time only. Second time, if you don't provide quality, that customer shall not come to you, shall not visit to you, rather be upset. Because remember, first first presentation, first quality, and then followed by second quality, and then followed up by further qualities. First quality is a submission, and other quality states or terms are representations of submissions. You continue of same state, and rather you add to value or you improve, and that's called reliability. Every time you sell your services, you satisfy your customer more and more and give more and more, and that's called quality reliability. Quality is a part of product. This is no separate item, you can say. Quality cannot be sold separately. If quality is sold separately, that's not possible. Product cannot be sold then. Quality is an integral part of product. Every product and every service, we know all that. Can we sell that? We cannot sell that. We can sell quantity only, product only. This means material in product and how it has been produced is a combination of material and quality, product quality. And if quality is good, you are welcome. If quality is better, you are better welcome. If quality is best, you are best welcome. Otherwise, you are kicked out. To be very frank, very bad term using kicked out. It's general term for some countries and very bad term for someone, but it's a fact. You are kicked out means your product is kicked out. You again some claims, and that's why I say quality and coordination. And coordination is something you have, so you can define in number of ways. Coordination is something that's only dictionary definition. Forget that one. It says that many answers move together, many responses move together, and combination of all that, effect of all that, one point is called focus of all representations, all answers, all responses, and we can use them at one time. There's no separate time for them. There's so many activities involved in projects, and so many sub-activities are also involved. And all these and sub-activities have certain timings, and if these meet, all these requirements meet at that time, it's called okay. We can use that. And if it doesn't happen, we can use this. हमें थोड़ा हिंदी में बता दें. क्वालिटी, गुणवत्ता जिसको कहते हैं, कोऑर्डिनेशन जिसको हम कहते हैं कि चलिए समन्वय करना है, तालमेल करना है, तालमेल बैठाना है, वो तालमेल वो जब हो जाते हैं तो बात कुछ और होती है. बहुत छोटी बात भी हो सकती है, लेकिन हम जब जानते हैं कि क्वालिटी हमारे देश की क्या है तो हमको समझना होता है इस बारे में. और क्वालिटी कोई मजाक नहीं है, कोई बच्चों का भी खेल नहीं है और कोई बड़ों का भी नहीं है. ये वास्तविकता है जीवन की. ये क्वालिटी तो आपको देनी पड़ेगी. अगर आप क्वालिटी नहीं दे पाएंगे तो बार हो सकता है आप किसी को धोखा दे दें, सामान आपसे को खरीद ले, लेकिन दोबारा नहीं खरीदेगा. और अगर आप क्वालिटी देंगे तो वो बार बार खरीदेगा. और ये भी तो ज़रूरी है ना. ये बात को हमको समझनी चाहिए, अच्छी तरह समझनी चाहिए कि हम क्या कहना चाहते हैं, क्या करना चाहते हैं. ये बहुत ज़रूरी होता है इस बात के लिए. और इसीलिए हम कह रहे हैं कि कोऑर्डिनेशन इंजीनियरिंग हो, क्वालिटी आवश्यकता है हर चीज़ के लिए, हर काम के लिए. हिंदी में दिखाना चाहता तो इसलिए क्रॉस कर रहा हूँ आपको, क्योंकि हिंदी में बताना ही बहुत ज़रूरी है, क्वालिटी क्या होती है, क्यों नहीं होती है, कैसे होती है, और साथ में ये कोऑर्डिनेशन का जो हिंदी में ये भी दिखाना है। समन्वय अभियंत्री इसमें लिखा है, योजना एवं अभियंता एवं सार्जन, सभी अभियंत्री बहुत जरूरी है समझाना। ये आखिर है क्या? समन्वय अभियंत्री योजना एवं अभियंता एवं सार्वजन, एंड यू कैन से दिस भारत इंडिया में गुणवत्ता, ये भी आवश्यक है। भारत इंडिया में गुणवत्ता, इसलिए मैं ब्राउज कर रहा था इसको। भारत इंडिया में गुणवत्ता किधर है, कहाँ बैठती है, मैं नहीं जानता। भारत इंडिया में गुणवत्ता कहाँ बैठती है मैं नहीं जानता। गुणवत्ता कहाँ बैठती है? अभियंता वर्ग में कोई भी गंभीरता देखने को नहीं मिली कि गुणवत्ता को कैसे प्राप्त किया जाए, परंतु कारण मुझको पता नहीं। बाजार में कोई भी पदार्थ गुणवत्ता द्वारा बनाया गया नहीं दिखाई देता। गुणवत्ता प्रमाण पत्र असलियत पर निर्भर नहीं है, बस एक सामान्य सी प्रक्रिया बनकर रह गए हैं। संस्थान सदियों तक चलने वाले ढांचे बनाती है, बाकी सभी का सामान कुछ वर्षों के वास्ते होता है। यही अंतर है सिविल तथा दूसरी अभियांत्रिकी में। कौन किसको समझाए पता नहीं, पर मस्तिष्क में गुस्सा आता है, ये सब क्या हो रहा है। फिर बोल देता हूँ, बहुत ज़रूरी है, इंग्लिश में हिंदी में दोनों में। भारत इंडिया में गुणवत्ता, वेयर डस एक्सेस क्वालिटी इन भारत इंडिया, वेयर डज इट सिट, वेयर डस क्वालिटी सिट। भारत इंडिया में गुणवत्ता किधर है, गुणवत्ता कहाँ बैठती है। अभियंता वर्ग में कोई भी गंभीरता देखने को नहीं मिलती कि गुणवत्ता को कैसे प्राप्त किया जाए, परंतु कारण मुझको पता नहीं। आई डू नॉट फाइंड एनी सीरियसनेस, आई डोंट फाइंड एक्जिस्टेंस ऑफ सीरियसनेस इन माइंड्स ऑफ, इन कंट्रोल्स ऑफ इंजीनियरिंग कम्युनिटी to know about how to get quality, and I don't know reasons about that. बाजार में कोई भी पदार्थ गुणवत्ता द्वारा बनाया गया नहीं दिखता। I don't find any product in market that has been taken care of having good quality in them or required quality in those products. गुणवत्ता प्रमाण पत्र असलियत पर निर्धारित नहीं है। It is also a fact that certification of quality that is granted by third parties do not amount to realities, but it's just like a general procedure, common procedure, and it doesn't have any practical meaning. It also like it may be government सरकारी संस्थाएं हों, it may be government institutions, organizations, और निजी गुणवत्ता सभी जगह है ही नहीं। और यू से दिस मे बी प्राइवेट ऑर्गेनाइजेशन और कॉर्पोरेट वर्ल्ड, you will not find, you don't find any quality existence. In nowhere you find any quality existence. And if you question, you cannot question, I don't find anybody question. किसी को भी कोई चिंता नाम की चीज़ नहीं है। नो वन हैज़ गॉट एनी काइंड ऑफ वरीज अबाउट दिस, कंसर्न्स अबाउट दिस। तो उत्तरदायित्व किसका होता है, बट हु इज रिस्पॉन्सिबल फॉर दिस, अकाउंटेबल फॉर दैट, दैट्स अ क्वेश्चन मार्क। अभियंता के, परंतु क्या अभियंता जानता है? अभियंता अभियंता इसका आंसर है, लेकिन क्या अभियंता जानता है कि क्वालिटी क्या होती है? इंजीनियर इज एन आंसर, इंजीनियरिंग इज द आंसर, पीपल रिस्पॉन्सिबल वर्किंग इन इंजीनियरिंग दे आर रिस्पॉन्सिबल टू द अकाउंटेबल, बट डू दे नो व्हाट क्वालिटी इज? दैट्स अ क्वेश्चन दे मस्ट नो, बट डू दे नो फैक्ट्स ऑफ दैट, रियलिटी ऑफ दैट। देश का गुणवत्ता बिना उन्नति कर पाएगा? शैल वी बी, आवर कंट्री शैल बी एबल टू प्रोग्रेस टू अचीव टारगेट्स विदाउट हैविंग क्वालिटी एलिमेंट इनपुट। और इफ़ यू थिंक इन स्वप्न में ही 5 टन की इकोनॉमी को हम चाहते हैं, और वी वांट ओनली इन ड्रीम्स वी शैल हैव दिस मच इकोनॉमी, व्हेन आवर प्रोडक्ट्स आर नॉट सेलेबल, इफ एक्सपोर्टेबल, हु शैल गिव अस मनी, हाउ शैल इकोनॉमी? There's a question mark and answer, who have to find, you have to find answer, उसका उत्तर भी हमको ढूंढना है। It's only merely एक imagination, it's only an imagination talking of नाम मात्र की कल्पना है, but there is no quality, गुणवत्ता है ही नहीं। तो केवल सिविल इंजीनियरिंग, it's only civil engineering that can answer this question, because civil engineering is the first requirement। केवल सिविल इंजीनियरिंग सदियों तक चलने वाले ढांचे बनाती है। इट्स ओनली सिविल इंजीनियरिंग वर्ल्ड दैट प्रोड्यूसेस मटेरियल्स, प्रोड्यूसेस प्रोडक्ट्स which work for centuries बाकी सभी का सामान कुछ वर्षों के वास्ते होता है. एंड ऑल अदर ब्रांचेस ऑफ इंजीनियरिंग व्हाट्सोएवर दिस आर ओनली प्रोड्यूस प्रोडक्ट्स दैट वर्क ओनली फॉर फ्यू ईयर्स. दिस इज ओनली डिफरेंस. यही अंतर है सिविल तथा दूसरे अभियांत्रिकी में. देयर इज ओनली दिस डिफरेंस बिटवीन सिविल इंजीनियरिंग एंड अदर ब्रांचेस ऑफ इंजीनियरिंग. कौन किसको समझाए पता नहीं. हु शुड एक्सप्लेन टू होम, हु शुड मेक अंडरस्टैंड अदर्स, आई डू नॉट नो. बस मस्तिष्क में गुस्सा आता है. ओनली माई माइंड गेट्स एंग्री एंड दैट्स ट्रू. हम नहीं समझाएंगे कौन समझाएगा. हमको पहले खुद समझना है, फिर हम लोगों को समझाना चाहते हैं, समझाना चाहिए, हमारी ड्यूटी है. इट्स माई ड्यूटी टू एक्सप्लेन टू पीपल व्हाट्स अबाउट क्वालिटी, हाउ दिस वर्क. इट डजंट मैटर. इट्स थिंक अबाउट क्वालिटी ऑलवेज. संचार तथा संतुलन अत्यंत आवश्यक है. थिंक अबाउट क्वालिटी एंड कोऑर्डिनेशन पार्ट. गुणवत्ता पाने के लिए यू हैव टू अचीव क्वालिटी. कम्युनिकेशन कोऑर्डिनेशन द मोस्ट सिग्निफिकेंट डिसिप्लिन एंड सब्जेक्ट्स. संचार आवश्यक है, तालमेल आवश्यक है, समन्वय आवश्यक है, अत्यंत महत्वपूर्ण है. इन सब्जेक्ट विषय ऐसा है, इसको पाने के लिए लिखित में दस्तावेज आवश्यक है. रिटन डॉक्यूमेंट इज ए मस्ट. मोबाइल से लंबी बातचीत का फायदा कुछ नहीं है. वी कैन नॉट यूज मोबाइल्स लॉन्ग टॉक इफ क्वालिटी इज नॉट अचीव्ड. इट्स ऑल्सो ए बैड क्वालिटी सिस्टम दैट यू टॉक ए लॉट. इट्स नॉट क्वालिटी टॉक. योर टॉक शुड बी लिमिटेड. योर टॉक शुड बी सब्जेक्टिव. इट शुड बी ऑब्जेक्टिव. And you have to allow others to talk, means you should give time to all. रिटन डॉक्यूमेंट्स मस्ट फॉर रेफरेंस. लिखित में वातावरण में लिखित में दस्तावेज आवश्यक है. सेम थिंग एज से विनिर्देश मीन्स स्पेसिफिकेशंस आर वेरी इंपॉर्टेंट एंड स्पेसिफिकेशंस कंस्टिट्यूट क्वालिटी. विनिर्देश मीन्स स्पेसिफिकेशंस एंड स्पेसिफिकेशंस इज द आंसर फॉर क्वालिटी, बिकॉज क्वालिटी मीन्स वॉट एवर स्पेसिफाइड यू हैव टू अचीव एंड दैट्स क्वालिटी. यू कैन से विनिर्देश गुणवत्ता प्लस हादसों की सुरक्षा, उपयोग, quality, safety, health, environment, and economics. These are all important contracts matters. गुणवत्ता means quality, हादसों सुरक्षा means safety, health, and environment. Environment means वातावरण अच्छा होना चाहिए. Health means सेहत अच्छी होनी चाहिए. शक्ति उपयोग ergonomics. Ergonomics means all these are interlinked. So गुणवत्ता बिना सब कर्म बेकार है. There is no useful work if there is no quality. There is no meaning of any work quality if work is not good, if product is not good. Who shall buy your product? गुणवत्ता बिना सब में there exists no quality in your work, in your product. It's all useless, irrelevant. उत्तरदायित्व अभियंताओं को गुणवत्ता प्राप्त करने हेतु. It's accountability. It's a responsibility of engineers to achieve quality. That's very impossible. Quality in construction, निर्माण में quality. क्वालिटी इन कंस्ट्रक्शन, क्वालिटी इन प्रोडक्शन, उत्पादन में क्वालिटी, मैन्युफैक्चरिंग क्वालिटी. आप जो उद्योग लगाते हैं उसमें जो भी प्रोडक्शन करते हैं, मैन्युफैक्चरिंग करते हैं, मैन्युफैक्चर खैर जो भी कहते हैं हिंदी में, उद्योग में जो भी आप प्रोडक्ट बनाते हैं उसमें क्वालिटी. क्वालिटी इन सर्विसेज, आपकी सेवाओं में गुणवत्ता. क्वालिटी इन एजुकेशन, शिक्षा में गुणवत्ता. क्वालिटी इन सोसाइटी, समाज में गुणवत्ता. क्वालिटी इंडिविजुअल और इंडिविजुअल मीन्स व्यक्तिगत गुणवत्ता. कितनी सारी गुणवत्ताएं हैं. क्वालिटी इन कम्युनिकेशन, संचार में गुणवत्ता. क्वालिटी इन कोऑर्डिनेशन, समन्वय में गुणवत्ता. क्वालिटी रिक्वायर्ड एवरीवेयर, हर जगह आवश्यक है गुणवत्ता. एंड इन एवरी एक्टिविटी, इन एवरी एक्टिविटी इन लाइफ, जीवन के हर कार्य में गुणवत्ता की आवश्यकता. इन इंजीनियरिंग अभियांत्रिकी में गुणवत्ता की आवश्यकता. एंड यू कैन से लाइफ इज इंजीनियरिंग बेस्ड. हमारा जीवन अभियांत्रिकी पर निर्भर है. विच मीन्स दैट इंजीनियरिंग इज डोमिनेंट ऑफ सुपर लाइफ. इसका तात्पर्य यह है कि अभियांत्रिकी एक तरह से एक बड़ा जीवन देता है, उसमें जिम्मेदार है. ऐसी वृत्ति ऐसा प्रोफेशन है जैसा हमारा चिकित्सा विज्ञान मेडिकल प्रोफेशन है, वो डोमेन है एक तरह से, वो भी बहुत बड़ा डोमेन है, जिससे बड़ा डोमेन कोई नहीं हो सकता. गुणवत्ता निर्माण में, जीवन में, क्वालिटी इन लाइफ, quality in life, quality in construction, quality in services, in every act, quality must be there. Education must be quality based, society must have quality, individual must have quality, as I already said. It is essential. We control our respirations, our breathings. It's like quality is our breathing, Pratt's breathing. If quality is absent, product has no meaning. If You can say your product talks to you. Maybe it doesn't talk voice-wise, but it talks to you. It tells you what it is about. And if it talks to you successfully, you will feel better. His response, सुरक्षा बिना सब कर बेकार है. There's no meaning of any work if there's no security on work. There's no safety on work. It may be production, उत्पादन हो, it may be industry हो, industrial work हो, और निर्माण हो. There can be no concessions. इसमें कोई भी रियायत नहीं दी जा सकती. No concessions in allowed in quality, and no concessions allowed in safety, health and environment. And it's very important. शक्ति उपयोग, आपकी एनर्जी आप कैसे उपयोग करना चाहते हैं. It is a method, it is a science, and that's called ergonomics. Ergonomics speaks about that. It's a science that requires everyone about how to use available energy within you. You cannot exploit your energy for nothing. Your energy should go to quality and production. No concessions on that. It's safety for everybody if you are safe, and everybody should be safe. These requirements are certainly most. In no way, no response can say. Who should ask yourself? You should ask yourself, must ask yourself. अपने आप से पूछिए, आपको पूछना होगा. No way out, कोई रास्ता बाहर नहीं चाहता विदाउट गुड क्वालिटी. अगर आपको रास्ता बाहर जाना है अच्छा बन के, अपने आप को संभालना है, अपने आप को आगे बढ़ाना है, देश को, अपने को, समाज को, अपने सामान को बेचना है, आपको गुड क्वालिटी लानी ही होगी. यू मस्ट हैव गुड क्वालिटी कंप्लायंस एप्लीकेशंस. अगर आप कार्य नहीं करते हैं अच्छी क्वालिटी के, अच्छी गुणवत्ता के, तो आपको कोई वैल्यू नहीं देगा, आपका सामान नहीं बिकेगा और आप ऐसे ही पड़े रहेंगे. गुणवत्ता अच्छी चाहिए, सेफ्टी चाहिए, हेल्थ चाहिए, एनवायरनमेंट चाहिए, अच्छा एप्लीकेशन चाहिए, उसका होना चाहिए जैसा चाहिए, नहीं तो सही तरह से आप नहीं जा सकते. नो कंसेशंस. कोई भी सुरक्षा है तो दर्द नहीं, सुरक्षा नहीं है तो दर्द. दर्द भी नो आप. दैट इज ए स्लोगन. नो सेफ्टी, KNOW, नो, नॉट NOW, नो, नॉट सेफ्टी. अगर आप सेफ्टी करते हैं, आप अपना सेफ्टी का ध्यान रखते हैं, नो पेन, आपको दर्द नहीं होगा. और नो सेफ्टी, नो पेन, अगर आप सेफ्टी का ध्यान नहीं रखते हैं तो आपको दर्द तो होगा ही. ये भी आवश्यक है. ये सब बातें रिपीटिशन की हैं, इसमें भी कोई कंसेशन नहीं. नो कंसेशन अलाउड देन दैट. गुणवत्ता की आवश्यकता हर कार्य में है. क्वालिटी इज रिक्वायर्ड टू बी एसेंशियल इन एवरी वर्क ऑफ लाइफ. एंड गुणवत्ता अभियंताओं के हाथ में है, और क्वालिटी लाइज इन हैंड्स ऑफ इंजीनियर्स, एंड दे हैव टू अप्लाई दिस, दे हैव टू इम्प्लीमेंट दिस. उन्हें इसको लागू करना होगा. नो कंसेशंस. क्वालिटी हैज टू बी कंप्लाइड विद. इट हैज टू बी कंप्लीट. इसको करना ही पड़ेगा, आप बच नहीं सकते. गुणवत्ता नहीं तो भविष्य नहीं. देयर इज नो फ्यूचर, देयर एक्सिस्ट नो फ्यूचर इफ डोंट अप्लाई quality, if don't get quality criteria, if you don't produce, there exists no good future, no bright future. Bad विकास होगा, गंदा विकास होगा, चोरों द्वारा, डकैतों द्वारा. This development shall be done by robbers, thieves, and you know what does it mean. क्या अभियंता गलत लोगों के हाथ का खिलौना होंगे? Shall engineers work as toys for such bad people? No future if no quality persists, and it is specified requirements must be met. It's that requirement which we complied with. बिना क्वालिटी के भविष्य नहीं है. and no concessions, no excuse is admissible for quality failure. क्वालिटी नहीं हो रही है, नहीं मिल रही है, इसके लिए कोई भी माफ़ीनामा, कोई भी क्षमा याचना नहीं है. गुणवत्ता आवश्यक, क्वालिटी एसेंशियल, नो कंसेशन अदरवाइज. क्वालिटी इज ए मस्ट एंड मस्ट. अभियंताओं को समझना होगा क्वालिटी आवश्यक है, जरूरी है, होनी चाहिए. इंजीनियर्स हैव टू अंडरस्टैंड. अभियंताओं को समझना होगा गुणवत्ता आवश्यक, नो वे, नो कंसेशंस. सिविल अभियंता वर्ग काफ़ी इसके लिए उत्तरदायी, बाकी दूसरे अभियंता भी उतने ही उत्तरदायी. Civil engineering community is responsible towards not achieving quality, and they are responsible to achieve quality both. And if you don't do it, they are responsible as well as lines are bad, simple. I'm just browsing this file to relax it just because already many times I've discussed this. मैंने बहुत बार इस फाइल में आपसे विश्वास किया है, डिस्कस किया है, वर्णन किया है, लेकिन जस्ट टू रिमाइंड यू व्हाट हैज़ अपन, उसकी बात मैं कर रहा हूँ, दिखा रहा हूँ आपको, क्योंकि मुझे कोऑर्डिनेशन पे जाना है. इस वजह से just refresh your memory that you were discussing fast in past about issues, very very important issue, and we have to be very serious about this time वगैरह जो भी है इसमें. अभी हम जाएंगे फाइल का रिवीजन आपको दिखाने के लिए, कुछ अमेंडमेंट्स भी में करेंगे. और सोच तथा एकाग्रता अत्यंत वेरी इंपॉर्टेंट पॉइंट. सोच तथा एकाग्रता अत्यंत आवश्यक. थिंकिंग इज एसेंशियल, वेरी एसेंशियल, एंड यू कैन से एसेंशियल, एक्सट्रीमली एसेंशियल. कंसंट्रेशन एंड थिंकिंग एंड कंसंट्रेशन आर एसेंशियल, you can say, to achieve everything. This is like powers. It's like powers, and it's very important. And Abhyantari is engineering. We know that Abhyantari engineering is business, and this is business we do. No concessions for substandard works, and therefore rejected these are, because it is against engineering and source nature. For natural materials are wasted without any optimum gains. Non-conformance means engineer is either careless if you don't do careful work, specified work according to specification. It is a responsibility of engineer. And non-conformance means engineer और अभियंता is responsible. अभियंता इसके लिए जिम्मेदार. अभियंता की लापरवाही की वजह से हुआ है, उसके अनजान होने की वजह से, उसके इग्नोरेंट होने की वजह से. और अभियंता इस चीज़ का सक्षम नहीं, इनकम्पिटेंट है, फालतू है, रिडेंडेंट है. ये बात में हमको समझनी चाहिए. गुणवत्ता प्राप्त करने के लिए लगातार कार्य सुधार की आवश्यकता होती है. इफ यू वांट टू अचीव क्वालिटी स्टैंडर्ड्स, यू हैव टू इम्प्रूव योर एक्टिविटीज, योर वर्किंग स्टाइल, योर कमिटमेंट, यू हैव टू इम्प्रूव योर थिंकिंग, एंड वट एवर क्राइटेरिया अटैच विद दैट एट्रीब्यूट, दैट्स वर्क. गुणवत्ता प्राप्त करने के लिए लगातार कार्य सुधार की आवश्यकता. इट इज कंटिन्यूअस इम्प्रूवमेंट दैट इज रिक्वायर्ड टू अचीव एंड कीप अचीविंग. अत्यंत आवश्यक सही गुणवत्ता पाने के लिए. इट इज़ कम्युनिकेशन, इट इज़, यू कैन से, इट इज़ कम्युनिकेशन एज वेल एज कोऑर्डिनेशन. एंड यू कैन से, यू हैव टू कीप योर क्राइटेरिया टुगेदर at all levels, and then you can say I am going to achieve quality. संचार तथा संतुलन अत्यंत आवश्यक सही गुणवत्ता पाने के लिए. It is most essential that communication and coordination are combined required to achieve quality. No concessions. बिना विनिर्देशों, स्पेसिफिकेशंस को समझे कोई काम ना करें. Without understanding specifications, requirement, please do not do any work. बिना विनिर्देशों, विनिर्देश मीन्स स्पेसिफिकेशन, बिना स्पेसिफिकेशन को समझे कोई काम ना करें. विदाउट अंडरस्टैंडिंग स्पेसिफिकेशंस डोंट डू एनी वर्क. क्योंकि गुणवत्ता प्राप्त करने के लिए स्पेसिफिकेशन या विनिर्देशों को अच्छी प्रकार समझना होगा. इट इज़ बिकॉज इट्स आंसर और रिस्पॉन्स दैट इफ यू अंडरस्टैंड क्वालिटी और यू कैनॉट अंडरस्टैंड क्वालिटी, बोथ हैव सम मीनिंग. इफ यू अंडरस्टैंड क्वालिटी, और यू कैन से स्पेसिफिकेशंस, or you can say directions, you have to understand, and only then you can apply. Otherwise you cannot do right work, you cannot achieve specification quality. लकीर के फ़कीर ना बनिए. You know there is a phrase, लकीर के फ़कीर पे, what's going to happen, we'll do. Say no, don't do that. If you do not think work is right, specified work, quality work, stop doing work without thorough understanding एप्लीकेबल स्पेसिफिकेशंस. अगर आपको स्पेसिफिकेशन समझ नहीं आए तो जल्दबाजी मत कीजिए, काम को समझने की कोशिश कीजिए, उसके बाद कीजिए. क्योंकि एक बार काम गलत हो गया तो दोबारा करना बहुत मुश्किल होता है. गुणवत्ता निर्माण में, जीवन में, सेवाओं में, हर कार्य में, शिक्षा में, समाज में, व्यक्ति में उतनी ही आवश्यक है जितना सांसों में, लिखित में दस्तावेज आवश्यक है. अपॉर्चुनिटी दें, दूसरों की बात करने का मौका दें. ये थी ये फाइल. अब हम चलते हैं अपनी दूसरी करंट फाइल, जिसको हमने नाम दिया है कोऑर्डिनेशन इंजीनियरिंग. कोऑर्डिनेशन इंजीनियरिंग आप सब समझते ही होंगे, बहुत बड़ी चीज़ तो नहीं है, लेकिन अगर समझ आ गई, आपके पल्ले पड़ गई तो बहुत बड़ी चीज़ है, नहीं तो ये भी प्रॉब्लमेटिक ही है। कोऑर्डिनेशन इंजीनियरिंग, अभी मैं कुछ ज़्यादा पोर्शन इंग्लिश में हिंदी में बताने की कोशिश की थी, क्योंकि सबका हक है जानने का, एवरीबडी हैज़ अ राइट टू नो व्हाट आई एम टॉकिंग अबाउट, व्हाट इज़ रिक्वायरमेंट, and coordination engineering is requirement of life. We cannot say no. Coordination engineering, you can say it's kind of very important engineering. In fact, you say there is no such engineering, defined engineering or recognized engineering, but there is no requirement of recognition as far as activity is concerned, because this is not independent, but this is dependent on already existing subjects. Coordination engineering is applied with subjects, not applied otherwise. And not only in the engineering, but in other fields as well, you can say. Whatever work you do in life, you have to relate this to other requirements. So take whatever work you do in life. I mean to say, even if you go to market and buy some materials, you have to coordinate which one you want, what's quality of that material, what's class of that material, what's your requirement, and you say where it's available, what should be my requirement, you can say. There may be varieties of materials in market, products in market, and you buy something and you know which is suitable for you, that you go and search. That's everybody does. Even if you buy smallest item, you go to market and search for that, and you don't buy at once. So this is either you have two criteria: you see price wise, you see, or you see quality wise. It's up to you. Sometimes you have no budget, so I own this, but so I don't least bother about quality. I want only to buy this cheap material, or you can say cheapest cost material. Cheapest, I mean economic cost, but otherwise, if you are a good buyer, you will consider both. It's my budget and my requirement is this. You can say, I can't spend more than this. So you look after something that's equivalent to that, your requirement, and for you at that time, that's quality. But what I'm saying is, coordination is something that you have to coordinate yourself. You have to understand. Your coordination may be different. I'm not saying it's just what I'm saying, right? It's you have to define which way you want to be, definition of quality, definition of quantity, and involve a budget and meeting requirements, or to some extent involved in quality coordination. Coordination, again and again I say it's same thing. If you consider graphics, that's a reference you can understand. I'm not saying graphic works here, but just to understand this coordination, we have to go to graph, zero x o x axis as we say, and y o y. Maybe those who don't mathematics, they say, unless otherwise, that coordination is something that has to happen at right time, at required time. What information is necessary to receive, that information must reach you at that time you are doing work. It should be even before that, it can be. But if work is done and then information comes, and that information got no value because it cannot be applied in your work. You got my point. आप कोई काम कर रहे हैं, करना चाहते हैं, उस काम के लिए जो भी सूचनाएं आवश्यक हैं, जो भी इंफॉर्मेशन आवश्यक है आपके पास है, और उस काम होने से पहले है, तो आप उसका यूज़ कर पाएंगे, प्रयोग कर पाएंगे अपने काम में। इसका मतलब समन्वय होता है। कहते हैं कि आपको तालमेल बैठाना है। तालमेल तो आप समझते होंगे, तालमेल बैठाना है। तालमेल अगर बैठ गया आपका, जिस समय आपको कोई चीज़ की आवश्यकता है, उस सूचना की, उस फार्मूले की, या उस मटेरियल की, उस टाइम आपको मिल जाता है, तो आप उसको अपने काम में लगा देंगे। और यही तो कोऑर्डिनेशन का हिस्सा है। और अगर वो मटेरियल आपको नहीं मिलता है, तो काम रुक जाएगा बीच में, आप काम गलत कर देंगे। दोनों में से एक बात होगी। बहुत सी चीज़ें होती हैं, वो सारी सामग्री आपको चाहिए होती है। हिंदी में भी थोड़ा बात कर रहा हूँ। सामग्री चाहिए आपको, टेक्नोलॉजी तकनीक भी चाहिए, आपको पता होना चाहिए काम कैसे होता है, चाहे वो कोई भी काम हो। आप चाहे दुकान कर रहे हैं, या आप अपना जॉब कर रहे हैं इस ऑफिस में, या अपना कुछ का काम कर रहे हैं, या कुछ भी आप काम कर रहे हैं, उसके अंदर एक कोऑर्डिनेशन का मतलब, कोऑर्डिनेशन सब जगह होती है, इसलिए मैं कोऑर्डिनेशन की जनरल बात कर रहा हूँ, सामान्य बात कर रहा हूँ। कोऑर्डिनेशन का मतलब सही समय पे सही इन्फॉर्मेशन आना, और सही समय पे सही काम होना, और जितने भी इन्फॉर्मेशन सही समय पर लागू करना, वो किसी भी रेशियो प्रोपोर्शन में क्यों ना हो। उसको हम क्या कहते हैं? तालमेल। जगह जगह अपने हिसाब से होता है तालमेल। जैसे आपने कहा जी मुझे ट्रेन पकड़नी है, ठीक है, आपको पकड़नी अच्छी बात है। उसके लिए आपको उसका समय पता होना चाहिए कि ट्रेन कितने बजे चलेगी। You must know what time that train starts if you want to use train. I'm just giving an example of coordination. Though it's known to you, but formally I'm explaining what is coordination. You have to go somewhere, so you have a train that has to go, and you know timings of train. This means You cannot immediately start 5 minutes before for your home and say, I'll get train. You should know about how many hours it takes from your home to that station, then how much time it takes from station entry to buy a ticket if you have not bought, then you reach that train and you will take some, you consume some time in inquiry. आप जाएंगे अपने घर से स्टेशन के लिए, वो टाइम चाहिए. अपने घर पे आपको निकल के स्टेशन जाने के लिए और वहाँ स्टेशन पर टिकट लेने के लिए और वहाँ इंक्वायरी करने के लिए आपको टाइम चाहिए. वो सब आपको हिसाब रखना होगा. और ट्रेन चलने से पहले कितने बजे आपको पहुंचना है, होना चाहिए वो मिनट, डब्बा ढूंढना है, सीट ढूंढनी है, 10-15 मिनट उसके लिए भी आपको चाहिए, सामान को उठाने के लिए भी चाहिए और घर पे तैयार होने के लिए भी चाहिए. ये सब टाइमिंग्स आप मिला लेंगे तो आप कहेंगे देखिए मुझे इतनी देर यहाँ लगती है. ये कोऑर्डिनेटेड कैलकुलेशन है, ये प्लस माइनस हो सकते हैं लेकिन ये तरीका है. और अगर आप इसमें से एक भी पॉइंट मिस कर गए तो वो टाइम आपका ख़राब हो जाएगा और वो ट्रेन निकल जाएगी आपसे हाथ से. इसी को कहते हैं एक तरह की कोऑर्डिनेशन. मुझे कितने बजे काम शुरू करना है, कितने बजे मुझे इन्फॉर्मेशन चाहिए, कहाँ से इन्फॉर्मेशन चाहिए, कौन सा यह सूत्र है जिससे इन्फॉर्मेशन मैं लूँगा, और इसी हिसाब से एक तरह का कोऑर्डिनेशन आप कह सकते हैं. ये कम्युनिकेशन भी है और कोऑर्डिनेशन भी है. जस्ट आई एम ट्राइंग टू एक्सप्लेन टू यू व्हाट डज कोऑर्डिनेशन मीन्स, हाउ इट रिलेट्स टू कम्युनिकेशन, हाउ डज इट रिलेट टू इंफॉर्मेशन, हाउ डज it relate to whatever sources we have got in and whatever required sources, and there may be surplus sources or not surplus sources, that's different issue, but minimum requirement is a must. And if I cannot follow that, I make some error somewhere, I don't care for that, I waste time somewhere, in that is definitely I may lose that objective to some extent. It's general formula, it's general and it applies everywhere. It applies. Why do you say we make out schedule, we make some timetable or time schedule for whatever activity? It's all because of that. A sequence of timings is required, a sequence of activities are required, and that's very important. Just like we say, okay, I'm going to do this project, I need some program, some schedule or schedule of timings. We generally call the time schedule. Or time schedule, that time schedule shall tell us what we have to do, it shall remind us all the time. Though we prepared ourselves also, we charted out everything, analyzed ourselves, and then we say, it shall remind us because we forget. Today what's in my mind doesn't matter, it shall remain in mind today evening. Got my point? If today, suppose at this moment I'm talking to you, I may forget after 5 minutes what did I talk to you, I will talk something else. It happens because of working mind. Continuity is important and you cannot keep your mind stagnant. आप अपने मस्तिष्क को रोक के नहीं रख सकते. जैसे कि कुएं में पानी को रोक दिया जाए तो पानी खराब हो जाता है. If there's a well and there's a water in well, if you keep it stagnant, that water shall get polluted and you shall not be able to drink that water. Same thing, flow is a must. If a river doesn't flow, it shall stop, the water shall stagnate, and there shall be so many complications in that water. If it keeps on flowing, it keeps on finding itself, because there will be settlement of heavy particles and there will be suspension of light particles, as well as, for example, there are grit in that water, there is sand in that water, something else, all will come down to bottom of the sediment, as well as you can say those fine particles move for some distance and then settle, and if we can say no particle of water shall be clear at that point, but incoming pollutants again shall spoil it. It happens in flow of water. So that's what I'm saying. Continuity of work is very important. Continuity of organizations understand is very important. Continuity of work understand is very important. What's required, we have to understand that, and that's what engineering says about. Engineering means complete use of mind. Your mind should be enough fertile that you can think on. Thinking is also a production if you think rightly. Thinking is also very much production. You can say you cannot do otherwise. So I'm saying you have to define coordination in a varying way. You see, it depends upon your own system. How can you define? आप कैसे किस चीज़ को परिभाषित करते हैं? या आपके हाथ में है, किसी के हाथ में नहीं है. आपको ऑब्जेक्टिव आपके साथ है, आपको क्या करना है, किधर जाना है, क्या आपकी मंजिल है, या आपको खुद डिसाइड करना है. कोई डिसाइड करके नहीं देगा. आप अपने ही वकील हैं, अपने ही जज हैं इस काम में. आप खुद ही प्रपोज करेंगे, खुद ही डिस्पोज करेंगे. That's what it says. You have to propose yourself, you have to plan yourself, you have to do yourself, you have to check yourself, you have to act yourself. Plan, do and check. इसलिए मैंने schedule की बात कर schedule. टाइम स्केजूल आपको बताता है किस टाइम पे क्या करना है. टाइम टेबल नहीं, टाइम स्केजूल. वहाँ मंथ की भी लेंथ होती है, ईयर्स की भी लेंथ होती है. इफ़ यू डू देयर इज अ 5 years program for this project, you have to complete the 5 years, then you have to 60 months time you have there, and these 60 months you have to define your activities. You have to chart out all activities. That's very important. And we can say analysis of that project activities. If you don't analyze, you cannot understand how many activities the project has got. And that's very important point, because you must know what work you have to do, what is the scope of your work, how does it move. It's very very important point. अगर आप ये नहीं जानते आपको क्या करना है तो आप क्या करेंगे बताइए. आपको तो पता ही नहीं है कि आपको करना है, इसके अंदर है कितना काम. आपको एक प्रोजेक्ट दे दिया, आप जानते हैं, आपने एनालाइज नहीं किया, बस हम कर देंगे जी, क्या क्या आप चले गए. लेकिन जब आपने शुरू ही नहीं कर सकते, आपको मालूम नहीं क्या करना है. आप चाहे बड़े इंजीनियर हो क्यों नहीं, जब आपको समझ नहीं है इसको क्या करना तो क्या करेंगे. इसको कहते हैं एनालिसिस, पृथक्करण करना, हर चीज़ को समझना. वी हैव टू एनालाइज एवरी पार्ट ऑफ दैट प्रोजेक्ट. Its analysis of that project in simple terms. I'm not telling you. It's very common sense part. You see how that project you should know what items it has, and that you can know only from drawings, from details. What details are there available? That this is total work done. These are so many quantities are there, and these quantities have so much items are there, and you should know all that. And if you do not know all those that, then you cannot do that product. You don't know. You will just stand in darkness and say, okay, this is my project. And you only speak, it's my project, I'm going to do this. You don't know anything what to do. So that was a quality, scheduling out for everything. And that's what I'm saying is coordination. Itself, it is a coordination that you have to know what is there in that. You are coordinating within yourself. You are coordinating with that project design. So you say, there are say 500 activities in that project, let us say. Then you should know what are those 500 activities. And if you don't know them, you can't understand what to do. Okay, you may miss something, but later on that comes to you, then you can incorporate that. There may be many components on a project, there may be many activities in a project, and there will be common activities, there will be independent activities, there will be dependent activities, there will be activities which keep on repeating. It depends on your knowledge, it depends on how you want to treat that. But you have to allow timings to all activities. That's the important part. You have to allow start problems, you have to completion problems, you have to apply each activity how much time it takes. It doesn't matter you go on searching and follow somebody to tell you based on your experience, you can say, because you have to keep resources optimal use, in optimal use. You cannot waste resources. That's not your duty. That's not right. You have to rather save resources. You have resources like, human being resources, you have resources like material resources, and you can say machine resources, you have information resources, you have whatever resources you have there, you have budget also. So these resources must lie within that budget. If you do not understand this common sense part, you don't need any formal training on that, because this is common sense training, experience training. It comes with experience, means no book can tell you about this. Books can only give you guidance, but your book is your mind. If you have good experience, you know what is required, what's not required, what's missing, what's not missing, what is redundant, what's not redundant. All this you know. Only then you can say, okay, fine, I'm going to do this, and I understand this, and this understanding is thorough understanding. It's called analysis of that contents of project, what project is, what quantities are, what you have to deal with, how you deal with, all that is required. We have to understand this point very clearly. And if you understand this point clearly, we can go a long way, you can say. We can go long way, and that's very important point. And once you understand that, you have to teach yourself in that case. No one shall come to teach you, because you have all details with you, and nobody shall stand with you to tell you. It is your teacher within you that lies in, and I call it self-teaching. Self-teaching is best professor, you can say. You are your own professor. You try to understand what I'm saying. You are a self-teacher, and self-teacher has got no limit. You are a teacher, you are a student, you are a worker, you are an engineer there. You have to direct yourself, you have to question yourself, you have to answer yourself. Can it possible? Do you understand what sort of things called coordination within mind, coordination within yourself, and coordination with your given documents, and understanding each other? This is called analytical talk, analytical engineering, analytical, just like I'm saying coordination engineering is analytical engineering. You have to make relations with that activity we are going to do. You have to understand that activity. The thing is, even if you do not understand activity, you can get information. How does it operate? For example, you are a civil engineer. You don't understand mechanical engineering. Okay, fine, no problem. But I can talk to someone else. And that is what you see. You have to seek information from someone else. And that activity, sub-activity, that timings or that work which you have to get information from others, it is called coordination information. Coordination information. You get information from HVAC engineer. You have to get information from electrical engineer, from other engineers which expertise is not yours. You get information from others, and both of you at that time, whosoever is there on other side, both of you get into some state of coordination. And for that means it's not complete coordination, but state of coordination in that activity. And there are many activities interrelated like this. Architectural, structural coordination, architectural decoration coordination, structural designs and architectural designs, compatibility coordinations, and likewise we can say mechanical engineering and HVAC coordination, HVAC engineering, electrical coordination, electrical and plumbing coordination, plumbing and HVAC coordination, and likewise whatever it fits into each other, we can say it's a state of coordination between various disciplines, and there will be multi-coordinations as well. It depends on what sort of work is that, what sort of activities are involved in. It's engineering activity or social activity. Even in social activities, you have to coordinate allied. Why delays are there in our world? Generally it's called that nothing happens in time in this country. It's not only this country, in many other countries I can say punctuality does not work. In majority of acts in this world, punctuality does not work all time. People don't value time, okay, it's up to them, but they should remember time loss cannot be calculated in terms of money, because even if you involve money in that, time cannot come back. Your money cannot buy time. Your money cannot pull back time. That's the only thing you cannot do. To pull back time is not possible. It's impossible. So if you waste time, you waste your resource. It is a resource, free resource given to you. It's not physical resource, but it's compatible resource. Time. Okay, cost you can spend, you cannot come. You may get profit from cost, but you cannot recover it if it is not recoverable. Cost you lose on time cannot be recovered. This time you could use somewhere else, but you wasted it. You allowed it to go, it has gone. What to do? So we should be very responsible. And this coordination is different, that's all I'm saying. If had you coordinated properly, you would have got something. That's my explanation to everyone. Then, when I say people are sleeping, it doesn't mean they are sleeping physically. I say they are sleeping in concern. They're not concerned. They are not, worried about. And we have to tell them be worried. Sometimes people worry without solution, and that has got no meaning. If I just keep on worrying, I don't have analytical solution, analytical answers, how can I solve problems? If problems are there, concerns are there, only way out is you have to solve them and find solutions, suitable solutions or near suitable solutions. And that happens because you have to keep yourself, and that's what expertise is. If you cannot keep like that, you're not professional. And professional means whenever it's the job of professional to go into in-depth studies of every requirement, every work, every proposal, whatever you want to do. As I said, I'm given a job, project, I have to analyze that product. And this is not mathematical analysis, it is activity analysis. We have to know what we have to work on in terms of quantity of material, in terms of requirements or quantum of workforce, same way how many machines hours we have to use, and which technologies we have to use, are these available with us, or we have to import them from other sources. And this is only requirement on projects, because we have to study that, and that without studying we cannot do anything. And I am also saying don't keep studying always, keep studying in parallel, and implementation another line, and then you can say quality another line, safety another line, of course sub lines, and all these studies we have to keep conducting, we have to keep understanding. And once we understand that, and I am not saying you study all items once together, at least try regulating them and start your work. That's very important, and everywhere you can find in some form or other existence of coordination requirement, and means to fulfill quality demands also it is a solution to that. And that's what I'm saying. समन्वय अभियंत्री, coordination engineering, योजनाएं एवं अभियंता एवं सर्जन, projects and engineers and public surgeon. We have to get into this for reliable quality engineering works delivery. हमें विश्वसनीयता के आधार पर जो भी प्रोडक्ट देना है, काम करना है, कोऑर्डिनेशन इंजीनियरिंग इज अ मस्ट. कोऑर्डिनेशन इंजीनियरिंग इज अ मस्ट. समन्वय अभियांत्रिकी एक आवश्यकता है. And this is just a page giving some information about that. And public must know, public को पता होना चाहिए, सार्वजनिक को पता होना चाहिए कि क्वालिटी आवश्यक होती है. हो सकता है वो समझते हों लेकिन जानते ना हों, या वो इसको एक्सप्रेस ना कर पाएँ. Why and how quality and coordinations are necessary. पब्लिक को ये ज्ञान आवश्यक है. That is my basic requirement to concentrate, to confer on coordination engineering. I consider coordination engineering as a path, as a process to achieve quality engineering, and support of this process of coordination engineering is communication world of communication, and world of communication engineering, in whatever way it may be. Every communication is valuable. That equips us with information which is available, how to use that, information which is not available, how to get it, and information that is being applied, what are its consequences, we know only by direct application or indirect application, in a requirement, in a specified way, in a defined way. And all these processes and in informed way, defined way, information, this and that, at right time you should get, and you should know what time information is required, and that is also called coordination, part of coordination. And that's what, यदि समझ में नहीं तो समझ अभियंत्री नहीं. If there exists no coordination, you cannot find clean engineering work. संचार आवश्यक, communication is essential. समन्वय अभियंत्री हेतु to do coordination engineering work. Communication is an important part in whatever form it be. Nowadays it should be very easy to do it, communication, but one should have capacity to communicate, and that is also important. Communication in time, right time, before it is delayed, before it impacts on other items, it should be done. Communication support for reliable coordination. It's not only coordination, reliable coordination that works. We have to see that point as well in every respect. Essentially, we can say we have to not just talk, and we have to understand this. And if we can do that, I think it's past way. As I said, I coordinated on many projects. Of course, coordination was one part, but responsibility also as a manager or organizer or leader, whatever you can say. Though I can work. Once you start working, you don't differentiate between what you are doing. What sometimes you have to work as you say, for example, I take a glass of water and drink. I cook myself my tea. What do you call at that time? Do I become office boy? No, I do not. But because it's a requirement, sometimes you have to do that. It's like that you walk yourself on your legs, you don't use other legs. You have no other way, you have to walk yourself. But you can say, okay, I can't walk, I have to use my car. So you convert your legs to car. You are using car, you don't use your legs. That's what's the point here I'm talking about. Means whatever you do, however you do, it's up to you. You have to decide. It's your decision, but process is coordination. As I said, it takes a lot of time to understand this, to understand yourself. If you say, no, I will go to some university or institution to understand what is coordination, and I think they will not tell you much more than this. That's the important point. Communication part, for example, we relate coordination to communication. Yes, communication is something that cannot be measured. It can be measured in timings only. You say this person talked on phone to other party. It took just 1 hour, 50 minutes to talk, or 1.5 hours. And you say there's nothing you can explain in 1.5 hours. It's only gossip, so I can say in that case, nothing else. If you think of work, if you think of time, it should not be more than a few minutes. It's enough. Until you say you write a book on phone. So it's in your hands. Communication should be useful. It should not be just funning yourself. You cannot just talk enjoying. If you are a professional, you cannot do that. Professional time is always very important. You are a professional, you are given a job. It's your time. You have to arrange yourself if you want to waste it or you want to use it. It's your own. That's its important lies in. So communication is very much part of professional integrity. Means out of your hours, it's up to you how much you want to waste in gossipism and how much you want to waste for nothing. And it's in your hands how many hours, what percentage of your time you want to use for professional works. And this time schedule you have to decide yourself, because don't forget you are a leader. You are a leader, professional leader, even if you are lowest rank, no problem. But it's you based on whose comforts, losses, or based on whose contributions many people would work. And because someone supervises you, you are a supervisor, you are a director of all those workers who work for you on your project. So you can say it's a very important part that you should not waste communication efforts, you should not waste coordination efforts. These are excellently provided to you free of cost, but your work should move and your work should give answer how much work has been done, what's cost of that work, and you feel good, I got this work done, so because of my acts, this institution, my company is going to get this information. And that's what I say. It's very important. Life, time is in your hand, cost is not in your hand, but in hands of resources to be used, and you can say cost, and you can say time and quality, which is third element. But here I am adding quality plus coordination. Quality means is quality that would give you how much you should get for this work of communication and coordination. Both are important points, and we cannot just get rid of these. And this was one project I did. It's a school project long back. I did it in 1985, 86, 86, 87, and really it was wonderful for me just to do something in that world without electronics. On this project, I see there was assembly hall. It was a boys preparatory school, and you can say 14 classrooms it had. Assembly hall of 18 meters span. 18 meters of span, you imagine. It's not very big. I cannot say this is wonderful, but at that time, in 1986, I had to construct 18-meter assembly hall. This 18 meters columns to column or span, you can say, and this was about 8 meters high, 8 meters from plinth level to roof level, or you can say slab to slab level, grade slab to its roof slab, structural level. It was 8 meters, and between these 8 meters and 0 meters, there were 4 meters certain fasciae, decorated fasciae, certain fin stripe, and this, of course, it was completely air conditioned area. So this has assembly hall, and also 14 classrooms in that one. There was a lecture hall as well, and of course physics and chemistry laboratories and others as well, workshops and workshop areas, mosque, substation, electrical substation, and all external works, and sports courts are facing, and many more, substation, etc., electrical substation, as I told, and infrastructure, external services called external infrastructure, as well as a septic tank as well. And you can say in those days it has to work very successfully on them. Structure was worked well. There was some coordination issues, and we resolved them because at the time there was no such coordination system. So it was used, if you are not able to do the job, you can just conduct some meeting, call consultants, request them to respond, call engineers representative, whosoever is for that. So this is for 1.5 years continuous coordination was done. And continuous coordination means so many problems were there which used to solve them. Though it's looking different now, but at that time it's the same way you can say in this. There's one building, the assembly hall, was at, if you see from this on left side, end at most point, it is assembly hall. Then we come down, and clockwise you can see this workshop, and further goes on, classrooms are here in whole row, and then so there is a plant room above. You see one small room, and then it goes to again lecture rooms and classrooms, and you can say furthermore downwards administration has offices of schools, and then because there's a mosque here in separate way. One mosque, if you see on right side top here, find a mosque, and this is just you can say assembly hall is 8 meters, and workshop is single height is 4 meters height, and then classrooms area are of course 8 meters, and you can say here in your lecture hall is also 4 meters height, and then you can say double, and of course you can see there go down upstairs that you'll find offices areas and mosque 8 meters high. Likewise, it's about beautifully 4,000 people per concrete. I remember 4 or 3,000 meters, 5,000 people per concrete was the structural concrete. And there were external works, you can say external works, infrastructure, firefighting, for example. And there were so many of you will explain to you in later elaborations. And sports surfacing, what we've done, how we got not comfort system, high standings of that time. And generally materials were purchased by this procurement for this material was from France, and generally many items were from France, and all concrete was taken was bought from ready mix concrete. And this was one project where so many conflicts appeared during site work, so many clashes appeared which you had to resolve. In those days for the issues, no question of here they had to use software for that, no software available. So it was different world and different type, and we did lot work in writing, writing work. You have to find quantities for every order of concrete. You have to find quantities for every order of block work. You cannot just get everything one time, and you have to place so much. You have to do metal submission for approval. If I work on contractors, then I'm saying in that case what we should do, procedures of this execution method should be there, and then activity method should be there. All these methods should be there. Only then we can say go to something. Same if you go further, we'll find that it's another project which is a project here. It was an entire portion of Daral Thaura printing complex. Same way I'll explain. Thing is available in terms of quantification, and that's very important. Here it is ethylene plant. I will also discuss about this. I written here, but it depends on mood, means when it's essential or not. But currently I'm just interested in defining what is. It's just another, it's a water body, artificial water body, and it's named as seawater basin. This was constructed one project, as I said above. And this is a big water tank, you can see reservoir type, and though it's a reservoir of we seawater is collected in this per requirements. It is about 100 meters by 50 meters. You can see normally I remember exactly, don't remember. This was done in 2020, I think. Oh no, sorry, 2000, sorry, not 20, in 2000 year. I reached this site in 1999 and then I started working on this project, and this seawater basin was one of many components of this projects, or constituent elements, you can say. It's a water body, and it was considerable size, and this was, you can say, a kind of water tank, open water tank below ground, and it has, you can see clearly, blue area shows water body, and from left you can say some pipes are coming. These pipes were 84 inches or 7 feet, you can say. Two pipes are there, 7 feet diameter, and then you can see on the right side here there's one building which is called pump house. For this pump house, and depth of this water body is up to you can see 9 meters somewhere, 9 or 10 meters, starting from few meters at one end, and then there is another inclined slab in between two, and there is RCC walling around, RCC base slab, and complete RCC tank and RCC pump house. So it is a water retaining structure as well as water storing structures, you can say. Water is retained, and then this water is obtained from sea. These pipes come from 2 kilometer distance of seashore. These pipes are run from there in the ground. These are run underground, and here these are taken up so that this can discharge water into in this tank, RCC body. This pipe run a long distance below ground. You imagine 7 feet pipe to 84 inches. 7 feet, or you may say 2.5 meter approximately. Two pipes come throughout this from sea, and that's another a kind of different. It's quite a long distance travel for piping. You have to excavate and lay this pipe. It's a big work itself. So you see how expensive it would be when you run these pipes from there and you bring it to this one, and this can be your epoxy pipe, GI pipes, or I mean not GI, say ductile and pipes or whatever you can say. This could be depending on requirement. And then it's very expensive, and then water is stored in this from here. Water is treated approximately, pump house and all that is there. So maybe some treatment provisions of chlorine, some, and then we have to transfer this water for purpose of cooling to every machine, whichever is designed for that. We have to provide cooling system for you can say cooling system for machines or equipments or engines or whatever you can say equipment where heat is generated. Where heat is generated by machines, heat is generated and we have to treat that by cooling so that temperature of that machine remains same and it doesn't overheat. That's purpose of this. It's very important purpose. You cannot just escape that one. We have to be very serious about that. Means purpose of this water body is not just because we have to store it. And there are quantity, size is also considerable, and it requires construction technique as well, because we have to first of all big quantity of water. Therefore base is also thick. Walls are retaining, of course, concrete walls and pump house, and then you can say it should not leak also, so it should be watertight structure, and that should be beauty of such tanks. So it was called basin in contract terms there, seawater basin. And of course we had one engineer there in charge for this project. I still remember, experienced engineer, very experienced engineer, who has expertise of flyovers construction. And I had some discussion many times with this person, and his Nakiran, it's called Nakiran, from Tamil Nadu. And we used to talk about this many times, because when I did not join, this person was there for coordination purpose, and this person did good coordination. But when I joined, he was given this job, and I was put in office, established, posted in office. You have to deal with this. He used to come to me for making queries, something, because it's my job to coordination engineering, and this person had a responsible job like this seawater basin. And so many times he discussed with him about something, and he said, I asked him, why you're casting 10 meters of wall height? I will cast it, no problem, I can do it. Means he had good experience, and many times we discussed with this. And when water test was done, I also was involved. There's some failure in this, but they arranged. It's no major issue. They arranged it successfully. And there's some problem, and we had to write some method how to do this water test. And then we made some statements about that, because I had to formally produce, based on his advice, his proposal, what was to be done. And we did that. And because there's, when we conduct water test, only then we can know how this failure occurs, or there's a movement in slab or wall, whatever is that. I mean, then we conduct this water test. Method was given, it's approved. But Water test means how much water is lost. How much water is lost and what quantity of water is evaporated due to heat. All these observations are required because actual quantity of leakage has to be known, and evaporation cannot be considered leakage, though it happens. We can consider leakage only through seepage, how many millimeters of level of water drops. And there is a procedure in BS 8007 that we cannot fill tank in one go. There is a method, maximum height you can fill in one day, and then you have to fill for so many days, and then you have to allow some period for, you can say, some period for stability of water with concrete, and autogenous healing we called it. Concrete's autogenous healing, and that should be done. So you can say there was a time scale required for this, and we did that. We made a list with the chart, how many days for tank filling is required, and how shall we monitor level fall, drop level fall during testing, though it's still filling time now. During filling time only autogenous action was required, autogenous consideration was required. Although healing, self-healing, you can say, kind of, if there are some holes are filled by water itself, temporarily, otherwise. And then important point was how to ensure evaporation loss, because no formula exists for that. There's no provision in any code that suggests how to evaporation. So only method was adopted, that we have applied some small, you can say, object we have to construct and put in floating form in that water, and we can say how much loss is there in our, because that won't leak, that object won't leak, it's only evaporation. So we can say evaporation millimeter, how many millimeter evaporation is, we could get from there. That whatever this means, whatever, of course it may not be exactly, but is this, suppose whatever millimeter of evaporation is observed in that small body, small object, means that happens on your reservoir also. So total drop minus that evaporation loss millimeters equals to net loss of water, and then to see whether it goes within limit of acceptance per code or it doesn't go, which is, there was no 500 mm or what is there, and you can say that was different one. So I'm just saying we did this one there. It's an important item, seawater loss, so we should know. And provision given BS 8007, maybe in European courts I did not try to find, should be there. And this is good one, means and it's only this, we have to test every water retaining structure. It may be above ground or below ground, we have to see that. Water tightness, it's called, water tightness is a must, otherwise it become, of course we have to apply membrane inside and outside, that's called protection membrane, just like we do in foundations, though there's no water body in that. In foundations we provide soil impact, we have soil impact on concrete, so we have to say we have to provide concrete protection, and this is explanation of that. Just for information I try to tell you, and I will explain to what's there in this later on. And now, because sometimes, and this is another body, it's a very small project, it is very small, you can see small building, it's called Record Center, and this is located in Masaid, Qatar. This is for petrochemical operation records, and this is outside that plant area, for in case plant gets fired, it gets replaced, records should not go away, and for that purpose this is standby record area, record building is called Record Center, digital record center. And a small building, of course, but very important one, because it's not alone here, it's connected to a remote building also on other plant, maybe 100 kilometers from here. So you can say it is kind of, you can say, what you call it, backup. It's a kind of backup building of records of plants So a small building, but there's a shelving system in that for purpose of digital recording. Digital records, shelving system is there in this. FM 200 is also there. FM 200 system, no immersion, FM 200, and of course very small but good one. You can see so heavy, high quality requirement control on this, and you can see on left down there's two tanks, probably water tanks. These are on ground, and on top left you can see some two buildings. One is electrical, and the other one is services building for all services. And on other one, if you see boundary wall outside, there's another project, another building area, and here on top, then inclined and vertical, then this is all boundary wall. And if you see on right side, there's a small building called guardhouse. Likewise, and there are landscape areas and see arrows on road, service road, and of course, some units here on top. If you see on roof, some chiller units, some other services units, and of course certain piping, etc. on this. So it's general, means I can say I still remember this because of Google Earth, and now this I will explain later on. Now we go, then it's another one. And good building, hospital, and you can say it's also voluminous work, though I was not involved in structure, but just for information I am showing to you. I was there for 6 months or 7 months in finishing stages, not in structural construction stage, and I, based on which I have done something here. And but what is there is also explain contents and specifications of this. It's always interesting, and this is Qatar also. This is, and this is I am showing this plant. That's LNG plant. It is called liquid LNG plant. This is located in Ras Laffan, Qatar. Here you see these 4 circular tanks. These are LNG tanks actually. Others are plants, other plants. These LNG tanks for storing LNG in condensed form. I think minus 80 or something degrees Celsius. Cryogenic steel tank within this concrete body. This concrete is for purpose of safety. In case your metallic tank oozes out, there should be protection of this gas not to go away. So this concrete tank would retain that in case of failure of this body inside, cryogenic steel and air. Now we come to coordination engineering. That is a must on every project. Every day I talk something about this, because without coordination, engineer cannot work. To be very frank, every engineer may be new or may be experienced or senior. It's responsibility of engineer to involve in coordination. Even if you are a designer or a planner or a quantifier or whatever you are, you have to know various stages of project. You have to know how it's going to be charted out for implementation. Even designers have responsibility. Designers have responsibility to involve in coordination, and they have to involve it. They cannot run away if they are real designers, because coordination applies everywhere. You have to coordinate within design itself. Otherwise, you cannot do design also. You cannot leave it to softwares alone. Yes, I don't say don't use softwares for designs. You have to use. But coordination cannot be taken for granted. Coordination engineering cannot be taken for granted, and it's only this reason I'm calling it coordination engineering, because it's very important one. Coordination engineering And if we don't care about this, we don't care about ourselves. That's also very important. And it's also a fact. I try to search on Google itself. Every day I try to search about coordination engineering, and am upset to say I find very little information on coordination engineering. If search for design engineering, lot information available. If you find something else, a lot of information available. But if on coordination engineering, I don't think anything is available in considerable volume. Coordination engineering, even quality engineering, you will not find anything important. And that's why my concern opened my eyes when I thought how it is that you are not finding anything. Communication engineering or coordination engineering, you won't find any specific piece of material. By chance we get something, and that's too not directly applicable. As I try to find BIM, I not only BIM in coordination engineering, and BIM also is not very reasonable. Oh, it's of course software, it works, but if you see application on projects, for maintenance it's okay, for maintenance purpose, for operational purpose, but for construction purpose, I don't think it's very much reliable. It may be, of course, because I'm not criticizing software, I'm not using it to be very frank, but what it says, what its details are available, well, I don't think that it's suitable for a construction engineer or for whoever they are. Even in designs, I can say it won't match that one, because design is a big process, long process, and you cannot coordinate that with the same. You need ready-made 3 days details, and if it's all ready-made means I don't think that designers would all that. They have that details. It's just a limit, and this means we have to be with our own coordination system. And that's what I say. Coordination engineering is a must for every project, and every person has different approach for doing coordination. We should understand that. And these are actually controls, we can say. Controls are important, and these are within designs there are controls, within construction there are controls, and in fact within controls there are controls. If you talk of design, and design is not a simple word, it's an immense volume word, but everybody cannot do all designs. If you say I do every design, it means you yourself are overvaluing yourself. It's not possible, because design means a full design. It's not simple one page. It's full design. This should be understood by those who are going to work on that. It should be full design, complete design, valuable design, time-consuming design. We know that design is not simply calculation. It's clear intuition in mind. It's approach what you are going to do. You know how to do that. What shall be? But you have to check it structurally. And that takes time. We have to do that. That takes time. If you cannot say, you join needs person as engineer and you know everything, you do not know anything. To be very frank, you cannot do anything. You have just something. So we have to analyze design as well. We have to analyze construction as well. How shall we construct this design? So design should give full information about construction to an extent possible. And you cannot run away because so much was required in this. I ask, do all this. Means we have to create design. We have to produce design engineers. We have to review our designs ourselves. Or so-called proof checking. So forget that. I'm not talking of that, but talking of ourselves. Peer review. If I design, you review means like that. Or I myself review myself. I become my own peer. So design is that. We should have complete information about requirements. We should have complete information about what sort of design it is. What is basics of this? What is philosophy behind this? What is the requirement of this? Minimum and maximum required. Minimum or maximum requirement. And also we can say, how shall we do it? That must also be kept in mind. And if you just say, no, I am not responsible for doing, I don't care for that, I just do it on papers. In that case, you are a defective designer, you can say. You are not a real designer. That's why I say, Design and construction are of course linked one. If design is done very well, it has been done perfectly, then this means that designer has kept in view, designer kept in mind while designing state of sight, though there is no sight at that moment. But designer knows what shall be problems of sight. If this design is done this way or that way, what should be result? How should we use on site? And that is where experience of designer lies. Means you have to understand requirement, you have to understand conduct of building, conduct of structure. Though there is no exercise, remember you should know how shall it behave, how shall it conduct, how can it conduct, can it deviate from that? All those points are required to be considered. So it's important job of design. Design is not, and it's not software that will design for you. Software shall help you, that's it. Concept software cannot give. You have to develop concept of what you are doing, what should be done. And then you have to keep in mind, as I said, buildability of your design. No buildability means no design, no cost. If you have designed something that's going to cause construction problems, I would say that design is no design. If you are causing construction problems, you are going to raise cost. And that is where I say it's obvious. Learning back, very elementary is good. Means everything is not ready made always. Even ready mix, we call it today, it's not ready made. It's mixed sometime. Therefore, we say we have to relate designs and construction together. That design plus construction is project. You got my point. Though there may be different parties, but designers are designers and constructors are constructors. There can be different people, different thinkology or different, you can say, power of thinking, power of concentration, and then controls are there. What is control here? In designs we have codes control. In designs we have requirement controls. Controls given by honor, or controls that are required. What people expect. Likewise, what experience says, and what code says, what conventions say. All these we have to consider, and moreover, budget. What does budget say? How much you have? Can you use that money for this, or do you have to borrow from sources? Designs has also many requirements. Means there should be complete information. And then construction people are not available at that time, of course. They are not available at time you're designing. Means you have to think from that viewpoint also yourself. Means you have to talk to those who have already worked on this. You have to talk to your seniors who have done a lot of work in construction, but who shall explain to others when you don't want to. That's what I'm saying. Controls and controls means construction controls, design controls, planning controls, quantity controls. All those come into picture. You cannot just run away. So I'm saying design, construction and controls are very absolutely interrelated requirements for achieving from successful start or commencement to successful completion of a project, which all must be applicable throughout project stages with all works be smoothly affected. So we have said in this project there is a design stage. In this project there is, of course, contracting stage or construction stage, and then there is closer stage or either retrofitting stage if it is continued. There is, you can say, very important points we have to think about this, that design construction controls are very absolutely required as a process of coordination engineering. As process of coordination engineering, I say coordination engineering means engineering that gives you, you can say, network. It gives you fulfill your requirement, and without that, you cannot do anything else. So we can say in this paragraph first, which all must be applicable. It says from start to finish, from start to completion, and which all must be applicable throughout project stages, with all works be smoothly affected. And a smooth effect of works. A smooth effect of works. These sections or stages are initial conceptual designs. These are initial conceptual designs. That's very important part. I'm just trying to see what's temperature, because 11 degrees, so it was 15 now 11. My God, that's why I'm feeling cold. It was 15 degrees at 3 o'clock, 3:30. Now it is 11 degrees, 4 degrees drop. Yeah, night is now saying 14 and day is saying 28. So that's why I'm feeling cold, and I think I should protect myself better. Now I'll search for coordination engineering. Also, if I get something today, I'm sure not going to get anything, but yet let me try. Let me try coordination. Let us see what it means coordination itself. It says, let us see what does it say for coordination. I'll just see coordination, what does it mean, and then we'll see coordination engineering. And the coordination says in dictionary, it's organization of different things, organization of different things or people so that they work together. Well, it's very normal. It's saying in Hindi it's saying विभिन्न वस्तुओं का या व्यक्तियों का समन्वय, संगठन, तालमेल, समन्वय. एबिलिटी टू कंट्रोल मूवमेंट ऑफ योर बॉडी प्रॉपरली, शरीर के विभिन्न क्रियाओं को सम्य रूप से नियंत्रित करने की क्षमता. It says okay, and it says coordination. Meaning of coordination is, this is Merriam-Webster.com. Meaning of coordination is process of organizing people or groups so that they work together properly and well. Also it says dictionary.cambridge said that coordination, organization, it is act of making all people involved in plan or active work together in organized way. And also it says coordination means organizing activity of two or more groups so that they work together efficiently and know what others are doing. And also coordination, act of arranging, putting things in order or making things run smoothly together. Fencing might seem like a breach. And in Wikipedia it says coordination, a compound grammatical construction. It is in linguistic form for language. It is coordination complex consists of central atom or ion. And so Macmillan dictionary says, Macmillan, coordination defines definition becomes the process of organizing people or things in order to make them work together. Coordination meaning, coordination is integration, unification, synchronization of efforts of departments to provide unity of action for pursuing common goals. I think this is better. It's integration, unification, synchronization of effects of departments to provide unity. And for example, 233 norms and norms for coordination, thesaurus, what are those? Let us say, I think this is, let me see, thesaurus, not get to say. Coordination, see definition, coordinations, allocation, allotment, analysis, arrangement, designation, distribution, grade, regulation, appointment, assignment, assortment, codification, collocation, consignment, denomination, department, disposal, disposition, division, equilibrium, gradation, grading, graduation, grouping, kind, order, ordering, ordination, organization, pigeonholing, sizing, sorting, systemizing, taxonomy, allotting, cataloging, categorizing, distributing, tabulating, typecasting, and these are synonyms only. You can say synonyms for coordination. And compare, if you compare them, let us say if you compare them, select up to 3 synonyms to compare. Let's say okay, let us say that arrangement, designation, grade, regulation. Okay, I think don't waste time in this. Logistics, equity, organization, orientation, physical fitness, and also you can say orientation, organization. So this is points only, we think nothing more than that. So we are going somewhere else and see means how can we more understand about coordination. To put same order of rank to bring into common action, movement and a movement of condition, harmonized coordination. Coordination is unification, integration, synchronization of efforts of group members as to provide unity of action in pursuit of common. So I think there is no much more indication on this. I think no meaning. Let's say it's coordination engineering. If I say engineering coordination engineering, what it says. Engineering coordination between design, engineering desk and on-site execution is of utmost importance to ensure successful construction. All right, what it is. Technical coordination in context of this study means working with influencing other people to, so say, constantly perform necessary work. And why is construction coordination is key in construction design, and this is to ensure effective integration between disciplines. Right expectations must be laid out before project begins. That's the important point. Let me see what it says. It is work coordination is construction key on construction designs. Most projects require input of several disciplines to produce a complete set of drawings and specifications required to erect a building. Architects, civil, structural, mechanical, electrical, and plumbing engineers usually comprise design team, while some complex projects may require other specialized disciplines or consultants. When design team efforts are says, as I said, architects, civil, structural, mechanical, electrical, and plumbing engineers usually comprise design team, while some complex projects may require other specialized disciplines or consultants. When design teams' efforts are poorly coordinated, drawings of one discipline may not align with that of another. If such errors make it onto construction drawings, there is a chance that building shall end up with a deficiency or a change order required to resolve this issue. Alert consequences of this nature. When design team efforts are poorly coordinated, drawings of one discipline may not align with that of another one. If such errors make it onto construction drawings, there is a chance that the building ends up with deficiency. We have to understand, likewise, this architectural drawing, there is floor plans, the roof plans, then you can say the elevations, sections, perspective drawings, structural design. What is structural design? Basing their work on preliminary architectural drawing. A structural engineers design a structure to support buildings that live and environmental loads, thus enabling it to remain upright. Generally, a building's structure consists of vertical and horizontal elements, such as columns, slabs, and connections between them. And structures, and you can say structural engineer job is to tailor these features to mechanical, electrical, plumbing designs. Mechanical, electrical, and plumbing systems must also make their way onto drawings before later are issued for permitting and construction. Having access to established structural and architectural layouts, MEP engineers get to work on their respective drawings and specifications. And other disciplines contributing to overall drawing packages may include landscape, civil engineer, communication engineers, acoustics, and specialty consultants and others, whose involvement may be required depending on complexity of projects. Common coordination issues. Coordination issue, also known as clashing. Clashing arise when drawings don't align well with one another. Common examples of clashing include columns obstructing the views of passages, misaligned slab edges, mechanical ducts running through structural members, and other instances where a disagreement between discipline creates an unbuildable scenario. This all I'm talking about stonework construction management. How to improve coordination to ensure effective integration between disciplines. Right expectations must be laid out before project begins. Architect and engineers must agree on set of deliverables that facilitate their team's coordination effects. These may vary from project to project, but at a minimum, architect should commit to furnishing engineer and how to improve coordination. Again, I'm saying to ensure effective integration, to ensure effective integration between disciplines, right expectations must be laid out before project begins. Architects and engineers must agree on a set of deliverables that facilitate teams' coordination efforts. Maybe there may be from project to project, this may vary, but at a minimum, architects should commit to furnishing engineer with some following critical information. For example, location of slab edges, floor to floor height, cavity depths, and ceiling interstitial spaces. Locations of slab edges, floor to floor heights, cavity depths, and ceiling interstitial spaces, parapet locations and height, unique architectural features, areas where design is expected to change in future. As a structural design moves forwards, engineers should in turn share the elements as such with architect. Location, sizes of columns, location of shear walls and other seismic resistance mechanisms. Location is types of expansion joints. The structural implications of proposed floor spans, lower floor spans and coverings. Same way, opportunities for improving efficiency of structure through changes to architectural design. As overall design evolves based of client's feedback, it's important for various disciplines to communicate changes they make so that everyone can stay on same page. Streamlining exchange of information, an important step in preventing flaws as different parts of design change over time. Today, you can say today Today, modern technology offers a great way to improve efficiency of interdisciplinary coordination. Processes such as building information modeling integrate various design inputs, facilitating and improving accuracy of clash detection. Peer reviews are also helpful in identifying systemization flaws and getting them fixed. With aid of BIM and construction management practices such as peer reviews, project teams should be well equipped to enhance coordination between design disciplines as well for complex projects. It always pays to hire professional construction manager. OC. What coalitions? This was from Stonemark and also Naukri.com. Forget it. Nature.com. Coordinating of iridium. No, it's not required. Selection of coordinates mechanism. No. So engineering management, operational design coordination. It's very old, 2004. All right, I close this. No issue. Now we have discussed about this design coordination and whatever coordination we say. As I said, so what I've written here in number 1, design construction controls are very absolutely in the relative requirements for achieving from successful commencement to completion of project, which all must be applicable throughout project stages with all works to be smoothly effective. These sectional stages are initial conceptual designs, designing for works execution purposes, procedural implementations about how to chart out constructions of design projects. So I am saying these actions or initial conceptual design for works execution purposes, procedure implementation about how to chart out construction of design project works, project construction works currency decision, and works carrying out testing, completion and commissioning, and launching use of project when project title terminates, renaming that title operation or occupation in place, you can say, in place of project. Designs may be considered oversafe. Of course, can be done oversafe, no issue. We can say this is oversafe design, but or optimum, but real construction involves actual expenses. We have to keep in mind. Oversafety is also not should be at expenses cost. It should be optimized. That's what I say. Designs may be considered oversafe or optimum, but real construction involves actual expenses, contract time, financial liabilities and buildings, professional reputation, both, which all must be cared of, which all be concerned sincerely by both stakeholders as such owners and engineer, designer at this stage, because contractor is not available at this stage. But you can take consultants You can talk to them about such issues. It should also be made a motto, you can say it should be a certain motto or an objective, you may call it, of an organization to you can say apply good controls on project so as to keep in line on schedule planning being an actual part of controls. You may say actual part of controls. Now control includes work progress cost. It includes lots of controls. Actually progress it is. First progress you have to control, then cost you have to control, cost escalation, time budget, quality requirements or assurances, coordination, engineering as well as total engineering, and safety risks covering and delays, recoveries. These are all integrated divisions which should move on unison to achieve project delivery targets. You know, a well-designed project could be jeopardized. A well-designed project could be jeopardized during construction phase from budgetary viewpoint should it not be given due required controls application properly. Now, without organizing with full intensities, keeping eager eyes on project and construction controls, no project can be delivered in time and fixed budget. First act of proposed project. Leader therefore must be get into allotted budget and then to move project within its defined ambit. One should remember that once money is lost, no possibility exists to retrieve that lost money back. Analysis tool can be required. Analysis tool can be required to operate with complete dedication to carry out or conduct controls. All required sections related activities import total dedication from quality input within such disciplines in actions as well as in words. Whereas all such acts certainly demand involvement of engineering coordination. Activities at each and every ongoing detailing, review and to ensure constructability issues. It can be plainly said that engineering coordination is an only formula or discipline to reach workable, consistent and competent solutions to achieve successful performance of every activity to be conducted to avoid many reasons. First of all, I am not experienced on that, and second is I think not to waste time, so we'll move to our own way. Quality and quantity and coordination. When you say coordination, this involves everything. It may not be basic operational factor, but it requires everything. It requires quantity, it requires quality, it requires timing, it requires everything. Because product means all are integrated information. minute. What is that? Minute distribution, you can say, minute. Coordination is very complex word. And many people don't understand this, unfortunately. As I explained in definitions, everything should go on as required. Everything should move. Every professional should move. Information should be available. Material should be available. Timing should be available. And it should meet at one point. And that's coordination. And it is very important to understand what it is, how does it happen. And it's not clearly understood by many, but it can be understood easily. And there's no way it cannot be. And it's really, as I showed to you yesterday, one plan of a complex. We see this is very big one, and we are doing. Now we are talking of only one plan. There were so many plans got together, and you can see them again if you wish. I was talking about that is, in fact, it was. In fact, you can say it was India Town Key Plan. And that is what it says. India Town Key Plan. It was. Let's just see that one. It's going to come to you now. As I said yesterday, I just gave an example of this. Example is there, say skill layout, and in this skill layout you'll find about 7 kilometer and about 4.8 kilometers. This. I'm not talking of area here. What I'm saying is there are so many complexes involved here. In this, so many complexes are involved here, and there are so many names you can see yourself. And I'm just trying to say, if you want to do coordination on this, how much input you have. It's not the whole world, but it's very small area. And if you want to do coordination and designs on this, what do you think about? As a planner, as an engineer, if you are given this task, what point shall you understand about this? How it has been accommodated? Okay, at random we can say it can be accommodated. We can say, okay, this is a complex area like this, and you see, it's just very patternized, you may say. These are roads, internal roads, all connecting, and various types of complexes here. We have put all complexes together on one page, and we can say, let us say names of these patients, just for information. Let's say here is a fire tender, and there's a you can say it's a carport, it's a market, it's a market, it's a market, and this is a general hospital, let us say. And what I say, general hospital is here, and then we can say as one Chintapuni is the name of this project, and here's Parvati here, and we can see Brahmastra here, Mahalakshmi. So all these are names, nothing to do with the engineering. It depends on what we were controlling that. And like all these complexes, you can see every side here are. Likewise, there is also some district center here. Now my point is not contents here, my point is how to coordinate on this layout itself, because the design shall be done later. First we have to finish this layout, and this layout is what you have to do, and then we have to take every details of all these buildings and all these complexes we have to consider. And that's why I say every point is different. It applies to whole area. You have to standardize that, and you have to do, of course, soil engineering before all that. While you enter design stage, it's just text. It's just the initial stage, and you say we have to acquire this much land and to develop it for purpose of all those who are involved in building construction. Just in building construction, nothing else. So you can say yes, it's interesting to note. And if you go into depth of studies, of this, you get many inputs. Now, here is, these buildings have to work together. Maybe say there's 10 buildings in one complex, 15 buildings in one complex. There can be any number. For example, I'll show another example here. This is a coordination versus project coordination versus project coordination and coordination practical. It's not that. It's not that. Let me go to. I actually lost something, I hope. Let us see. File open. I open some file, and which is here. General request, general record, service quality, general record, recent files in here. and this is India T-Clam, Coordination Engineering, Quality FI, not this that one. I think it's not coming in here. Plan shipbuildings, PDF, download key plan, Eurocam. So let us see this plan shipbuildings. For example, we say, I open this plan shipbuilding, and it is here. Is that is here? I think this is here. Yeah, it's the plan shipbuildings. You see, in this, it's just a typical dimensions here I've seen. You see, these shapes are like this, for example, A, B, C, D, etc. These are shapes of this building and are taken up arranged in that plans, and there may be many buildings in that plan. And let's say if I close, I'll open that plan. Say example one plan I open, and it works. Maybe it's general record. I don't know where's that, but general records. And this is, I think, in my this is somewhere in this. Oh yes, I have in my own letter. It is book plans I have. I will show you that. The book also I'll discuss later on. And this is building practice and career photos drawings, not this one. And let us say I have here this place. I'm just finding that file. It should be available in my folder. This is management documents as a book facilities and book method and book plans. Let's say I open this town drawings and okay, these are all drawings. I'll go to book plans. Then yes, it's there. I think 6, 10, 20, 13, 6, 10, 10, 10, 10 is there. Let's say here is yes, so for example here the simple is 1, 2, 3, 4, 5. Let's say as just for reference. Now it's a complex of buildings. You can say its dimension is 685 meter this way and 460 meter that way. Now here I come from those details 1, 2, 3, 4, 5. Let's say 6, 7, 8, 9, 0. These are buildings available in this plot. Plot is 685 into 460 meters, so it's big one for you, but let's discuss about this. 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. These are distances. The distant from each other, 1, 2, 3, all these are having big gaps in these buildings. And here is a carport. There's another carport, means isolated parking, means not fragmented parking. We have to park in one location. And there's a substation for electrical supply, has a police post area left, and there's a school area, and of course there's a green area, and then there's a community facility, and there's so many pools, swimming pools if required. And I'm not saying you do it. There's a medical building, nursing home you call it, and this is local market. And there's a substation, of course, like here was here. And then this is, it's just like minimum facilities that can be provided. You can add to these facilities. There's no and all area otherwise screen. You can also find roads here, arrows. This indicates something. Entry is here, and of course some entries here, big area. So many entries here, and these are all internal roads. So you can see all these internal roads here, and all these are roads. And of course roads, and because these are all service walkways around buildings, and you can add more to this. Now these are all walkways, you can say walkways, and all this connecting the road here. And this, I am saying, this is a kind of calculated architectural town planning design. Now this is to limit the design, but now we have to start. If we stay, you do it, develop it. In that case, you have to start coordination from this stage itself. Coordination from this itself. This means you have to know first of all. This is a big area. You can say this. Let us say how much it is. 6.68 f, or you can say this is meters. 6.685 meters kilometers, and this is 0.46. So it's so many square kilometers. You can say. one less than 1 square kilometer it is, was meter wise it's quite big. And how much is that? We can say, let me see how much it should be. Let's just say 685 into 460. And if you see 685 into 460, 685 into 460, how much it should be? And that's a point of concern here. I can say it should be about, if you take in meters, square meters, this should be about 315,000, 315 and 100,000. And it should be 315,315,100 square meters. And if you take this, how many square kilometers it should be? Then we can say it should be this should be 0.315 square kilometer. Now, if you, first of all, if you do plan coordination, you can do, then you can coordinate each and every building in the whole. Because if you want to say we have some water reservoir here on site somewhere, not shown in, but how much water to supply from that reservoir to all this is a part of technical coordination. Then about the supply of electrical current, that your substations are here, you have to receive substation here. Receiving substation, you get supply from main power station, and then how it has to move to all this is also technical coordination, technical requirement. And same way you can say this carports, how many car parking, how many cars you allow to a family, and how many families are going to stay in these buildings, in each building, how many cars are required. Of course you have to see, and how many swimming pools you have to provide depending on that, and overhead tanks are here, and overhead tanks you want to use, or you want to use pumped water supply, that you have to decide policy. And of course there should be according to the reservoirs below, and the reservoirs below all buildings as well. And how many percent green area you want to give? You want to give 85% green or 75% green area, what's that, And this we call the residential mansions, and all these required, so you have to calculate how many children should use this school, how many students should use school, and what should be size of market, and what should this market help, and what should do, and then medical nursing home, how many, likewise, these are general requirements. And we have to, first of all, there are various levels you have to think about, we have to coordinate about. And when you say, okay, we have, for first this is of coordination or planning, you may say, so planning also part of planning, so planning coordination it is. Then when we reach to that coordination, we got coordination engineering, means technical coordination. When you start designing from structures, depending on soil investigation, we design foundations, and we have to see what the state of this, or we can say technical requirement is, whether this strata is good for this area or not, and we have to improve. Because it's not localized area, means the soil investigations may vary, soil strata may vary, water levels may vary, and we have to see. It is all requirement of technical nature. And just like you can go on, then when you reach initial building design or initial flow design, and that time you say, oh, this type of coordination is required, or that type of coordination is required. And that's a very important point. And I just try to show you what actually we are doing. I'm not going to in-depth study of that. There are many more plans we can say in this. Let me show you another plan also. For example, here say there's I'll take something very different so that you should not feel upset. And let's say there's another project. It's called Namaste Salam Sat Sri Akal. Now this is heading of buildings, Namaste Salam Sat Sri Akal. But same way provisions have been made here about facilities, all that, and it's also kind of, I've taken this into a book form, and that's called books plans. And we'll discuss this soon, and just trying to keep you informed means what does coordination means, and what does it means. And of course, in this position, we have to think of a lot. The purpose was only to let you know what I'm talking about, and that's coordination engineering, which is applicable everywhere in every branch in different modes. It can be detailed coordination, it can be superficial coordination, it can be policy coordination, it can be what a coordination we can call it. I'm using this term coordination for everyone. It includes communication. When I say coordination, means communication is included, and you can say multidiscipline levels are included, multi-disciplines are included in this. And of course, quality is integrated with this, because coordination, there should be quality in coordination. That's why quality is included. There should be speed in coordination. That's why quantity is also included. And there is a coordination sequences must be included, just like we say we have to plan. We have to plan activities. This is how to plan coordination sequences also. Those are part of planning. It's a kind of execution. And this planning means coordination with everything. Coordination has got relations with all works, all activities, all domains, engineering wise, otherwise. Coordination is something, it includes layers also. Communication means you must have capability to coordinate, technical coordinate to other coordinations, or you can say managerial coordinations, or you can say cooperative coordination, you can say whatever you can say, collaboration as well. And you have to define your expertise, you have to use your knowledge. And when you are an engineer also, you have to use your engineering knowledge, and you can say your product shall be expected to be much better than all others. And that's the purpose of engineering, because engineering doesn't end, it starts there. Coordination. This coordination means we are equal, and we are talking about this. Our interest is objective achievement, and that objective is project. And it depends on where you're working, and that's the coordination is clear, and we have to understand it. And this explanation, I'm just giving elaboration, I'm giving to understand what coordination is all about. Coordination cannot be just thoughts, just one or two boy or game or together, just like many definitions told. Two or more persons sit together and discuss something in a proper way. Okay, that's minimum requirement, maximum is, there's no limit. There can be coordination team, there can be coordination meeting, there can be coordination, you can say association, there can be something else. We can start that. Okay, we have constituted this team of 4 or 5 persons who will coordinate all this, and then there can be only one person, depends on type of coordination of that. What's important is, and in fact coordination is called engineering itself. I equate it part of engineering and engineering world, or it may be something else you can say. The fact remains that without adequate and efficient coordination in professional engineering works cannot be successfully accomplished. And it's very important part that remains, and fact remains. It's a factual that without adequate and efficient coordination in professional engineering works cannot be successfully accomplished. If I could claim, it shall be right to admit that coordination failure leads to engineering designs and construction failure. There is nothing incorrect in this. I had to claim that if I fail in coordination, I think it's the right way. Why should we fail in coordination? It's because of I'm not aware of that, or I am ignorant, or I don't want to concentrate on coordination. This means I don't want to acquire information, related information. I leave to others, and others don't cooperate. So even a single point fails, it impacts all other points. Imagine something that you have all work done except one item, and that one item can hold your work. It's a big problem for you, because you are too upset at that. You can become too upset at that time. So that's why if we could claim, it shall be right to admit that coordination failure leads to engineering design and construction failure. There's nothing wrong in that statement. And that's why I say in follow point 4, many engineers, issue of coordination remains very, very delicate. Delicate because it requires concentration, it requires commitment, it requires to follow some route. You cannot just live out of that without having final solution or a group of solutions. That's why I say for many engineers, the issue of coordination remains very delicate, and such engineers try to avoid involving in coordination and complexity, and just expect someone else should give final working drawings for work execution. This means you want to move forward based on others' works. You don't want to do your own work. So that's why I'm saying for many engineers, issue of coordination remains very delicate, and they want to keep off that. And such engineers try to avoid involving with coordination and complexity, and just expect someone else should give final working drawings for work execution, and they should do it. That's it. That's what their objective is. This means they don't want to take risks, they don't want to think, they want to concentrate. And then they are not fully engineers, you can say. Engineering means concentration. Engineering means concentration, focus on something. It just means thinking on that, and that's a very important point. And thinking means engineering. And if engineering is there and no thinking is there, I cannot call it engineering. That cannot be called engineering. In fact, I experienced this a little long back. Around the whole world, people are very least interested in coordination work. Very few engineers are interested, not all. In fact, I experienced the engineers from around the world, whole world scenario, majority engineers population do not have any interest in working on coordination activity due to essential requirement on concentrating or focusing constantly on engineering and in-depth technical issues involved. And though they are engineers, some people are not interested in such office activities or in such imaginary activities, though these are not imaginary for time being, but later when this can be put to shape. And that's where I say it's very important. And therefore engineering is difficult in this way, that you need presence, you need concentration. You cannot leave it to tomorrow, or you cannot leave it to next time. But you have to think, even if sometime you prorogue it, that you will wait for 2 or 3 days for this information to come. But that issue keeps in your mind. You cannot exhale that, you cannot delete that from the omit that. That's what it says that I'm just writing this all because you have to understand something. And problems are not counted in numbers, that's not issue here. Problems are not counted in numbers, but in considering gravity of situation, complexity and strong decision making related to whatever work items are involved, and that's a very important point. And we can say problems are innumerable, or it is in magnitude, we can say different volumes, and we have to value accordingly, and it takes time accordingly. But once you make yourself completely immersed in coordination, then it is nothing for you. You can even change whole design. But in considering gravity of situation, complexity and strong decision making related to whatever work items are involved, coordination definition is for sure. Coordination definition is for sure necessary to be understood for its real meaning, so that no mixing results in. And that's a very important point. Coordination definition is for sure necessary to be understood. That definition we have to understand in entirety. Coordination definition is for sure necessary to be understood for its real meaning, so that no mixing results in. We have to avoid mixing opinions, or we have to avoid mixing which should not be mixed. We have to keep independent, but we have to avoid mixing. And mixing is bad for us itself, for designer itself, for project itself, for detailing or drawings itself, because mixing can create wrong design. It can create misconception. That's why I say coordination means it's a big change in engineering. It can change. Maybe by lack of information you take something, you assume what's given, but when you see in field, oh, I took this, but this is not working. It happens. Means I tried to reach somewhere, I could not reach for some reason, and I lost my time, I lost my information. Whatever is possible can happen. So we can start. Let's start mixing should not be there. What I have to do, I have to decide. I cannot take 3 or 4 opinions and go on and discuss with people. It won't help. We have to be serious again, I say. Coordination definition is for sure necessary to be understood in reality. In reality, it should be understood what does it mean. If you can say, in coordination definition is for sure necessary to be understood for its real meaning, so that no mixing results in. Mixing doesn't mean, whatever you say, mixing means a state of confusion or non-decision or a state of dilemma. You can say, on horns of dilemma you stand. Mixing means a state of confusion in work. And state of confusion meaning indicates that the right activity cannot be accomplished at the right time. That's mixing. We are confused. You can't decide. We have to come out with mixing. And sometimes, you are hung up. We have to see all these points here. In true requirement to spread means say mixing means a state of confusion in work. And state of confusion meaning indicates that right activity related to work cannot be carried out at right time, and this means we have to miss right time, and that is not acceptable. When you require something, you should know beforehand what's going to be required, and you must have that. That's called coordination competence. Coordination competence also we can say mixing means a state of confusion work, and state of confusion meaning indicates that right activity related to work cannot be carried out at right time. In construction world, particularly structural and buildings construction, no limitation of drawings and details exist. It depends upon you how many drawings are required comfortably, how much. We don't scare people with drawings, but drawings are not easy. There is time and time is not necessary. Then we can go through in construction world, in particularly structural and building construction, no limitation of drawings and dealing exists. Even for a small building or structure, categories of drawings and details remain same as if it could be a major building. It depends on designing professionals about how they apply drawings and detailings. It depends on designing professionals about how to apply drawings and detailing, so that construction personnel should not refer back every time, for either confirmation or clarification of various issues involved. Coordination can therefore be defined. We have to define coordination that way in our own definition, practical definition, not dictionary definition. You can say coordination can therefore be defined in a way that all branches of engineering involved, and you can say, and all disciplines involved in ongoing activity must be clearly described and detailed in, so that no information is left out that could hold progress on activity or part of whatever activity. Coordination can therefore be defined in a way that all branches of engineering and all disciplines involved in ongoing activity must be clearly described and detailed in, so that no information is left out. That activity that could hold progress on activity or part of whatever activity. If even one small information is held or is not available, even one small information is held without having adequate details, or is not formally confirmed, that activity can stop or it shall be carried out. It depends based on either correct or incorrect knowledge, both. It may be correct knowledge, it may be incorrect knowledge possessed by site worker, site team, which work could be considered in contravention of what the designing team contemplated. Consequently, it shall be certainly leading to a cause formal errors. This is very different one, because we have complete information. If we miss one information, the site team has no patience, they can't wait and they do something which is not to be done, or say cause some errors. We can say that way is it. If even one small information is held out, it's not available without having adequate information or details, it's not formally confirmed. Activity cannot stop, or it shall be carried out based on either correct or incorrect knowledge possessed by site team, which work could be considered in contravention of what designing team contemplated. Consequently, it shall be certainly leading to cause far more error in that work. And that can be called impact of bad coordination, impact of missing coordination, you can say. It also remains a fact that no subject or no branch of coordination engineering is available for imparting professional education at whatever or any either diploma or degree or up to post-graduation level. There is no such subject, and that's unfortunate. This means you can only learn yourself. You cannot get information from literature, but if you want, you can start your own literature. And that's important meaning, because so you can say, since no subject is available, we have to be worried about this, and the absence of inclusion of very significant subject. There's no subject at all within engineering program explicitly indicates the intends that in education professionals do not understand value of engineering coordination, and so we have to do it ourselves. And engineering will not teach us, education will not teach us, a practical experience can teach us, life can teach us, project can teach us, and what is available information in field and projects that can teach us. And that's what we have to rely upon, and we have to read all documents, all the specifications from time to time. And there should be no work that we can do without understanding clearly in terms of how to apply this decision. We have to also make sure that this is the same price, the same item that we have. We cannot just skip that one. So moreover, it can't be called educational fault because they do not know the activity and field of engineering professions, and therefore no subject to attaining practical field professional experience. It's also important point. Coordination engineering is an unlimited world. Coordination engineering is an unlimited world, and it can expand its vistas to unlimited areas, involving many disciplines in one branch, of engineering, and also importing various branches of engineering depending on what class of works are affected. We also seen an era of coordination activities when there used to be no electronics related technologies, or we now call it information technology, but wherein lot voluminous works used to be carried out on civil, electrical, mechanical, and architecture. Even in era work coordination is done already, you think, see? Even in era works coordination was very much time consuming, due to the fact that even drawings, you can say, even drawings used to be manually drafted or drawn. You can say coordination engineer would have been appointed, had incumbent professional, inexperienced on considerable size projects. So what I'm saying is very important point. We have to discuss about this in coordination engineering. It's not blank one. It's a perfect one. It's very powerful. And without this, we can't move a step in these days. So say coordination engineering would have been appointed. Coordination engineering was appointed, had incumbent professional, been experienced on considerable size. You cannot appoint everybody as coordinator. Only the person who has got experience, wide experience on multi-level, having conducting operational work, only that person can be avoided. You cannot appoint in this position every A, B, C, or D. There's no room for everybody. So say coordination engineer would have been appointed, had incumbent professional been experienced on considerable size sites, and that's a very important point. If one is not experienced, you cannot give this responsibility to that person until that person has exposure to coordination. And of course, it's a very important point that there is everybody who knows something, who has gone through such projects and who understands complete technology of that project and procedures on that project, that person can help it, and that's a very important point you have to see. To understand that point clearly, only then we can say, yes, it's okay, fine. And that's where we can say something can be done, something should not be done, or be done, or what should preserve, what's the precautions taken, what exemptions, what planning it is, and how planning is, how helpful or what's no. Because superlative planning should be real required planning, and there should be technology which is methods which are adopt. Everything should be known to that person, and that person is called different type of engineer. You cannot simply say this is a civil engineer. It's coordination engineer, you can say, an engineer who can deal with all such issues. So that's why I say coordination engineer would have been appointed had incumbent professional been experienced in considerable sites, and whosoever professional having just one engineering discipline knowledge could not be successful, efficient working on site and progress. Consequently, either merit or errors, mad or errors caused. We have to be very careful about this. Meanwhile, I'll give you something here that I'll so that I can come back and you can rethink on how to coordinate, how to do it successfully in a way it should be done. I'll see, just please 5-10 minutes, I'll come back. So we continue with this is very important point. The coordination, sorry gentlemen, till 5-7 minutes later. I said such helpful way. We can continue our talk with this and we can say that what we say is that we can say, as I said before, considering engineering would have been appointed. I said such unhelpful situation. Forced professional engineers to work long hours in those days when there was no such arrangements of digital world, computer world, internet world, and there was nothing as such except drawing. Yet 17 FPS only, video and audio 0 both. I can't guarantee anything at this moment except that you can see that nothing else, but still 0. Maybe everything is lost. If something has come, so I'll continue. Such unhelpful situation. I don't know what's happening here. Why is this like that? Let me wait if some signals come. Yes, it's still 0, so I think we can't continue, right? We're going to die soon. Something has come in again. So an understanding of coordination definition and respective description makes certain difference on works. We may not call it teamwork, but for sure, because coordination cannot be done effectively by team. Of course, it can be done different way, but by providing information, but not exactly coordination, you can say. But certainly, as well as on other documents. And of course, professional market prevailing conventions. Members and of course members of project team are required to extend engineering support, and of course members of project team are required to extend engineering support to engineering coordinator, without whose input no coordination activity would move, whereas as well as necessary examination or investigation of all details. Now, I say coordination is never-ending activity. It's never-ending activity. You can say it always continues as far as project moves. As long as project moves, you can say to whatever distance project moves, to whatever time it takes, coordination moves with it, in whatever degree of requirement. Coordination is never-ending activity. You can say which therefore cannot be considered time-fixed activity. Cannot along with other contract documents. Means coordination is a never-ending activity. Therefore, no time can be allowed to this. It's same time as project time, even more than that, and it depends on design mandate and scope. Special materials producing manufacturers such as document